Looking at the union of events, when these events are not mutually exclusive, right? So I'm going to put that big over there. They are not mutually exclusive. Now, what happens in the case if they are not mutually exclusive? We've seen simply the union of events. If they are mutually exclusive, is I just take the one probability and add the other probability. Now, you've already seen an example of this earlier, but now we are going to introduce the formula for this particular case, right? So the probability of a king or a heart. You're going to say, well, Imaad, we've done parts of this. Probability of king or probability or drawing a heart, right? So my chances are increased because I've got king or I've got heart. And this is going to be as simple as saying it's the probability of king plus the probability of heart, okay, minus the probability of king and heart. Right. Now why do we do this? You can say, well, the probability of drawing a king is 4 out of 52. The probability of drawing a heart is 13 out of 52. But inside this, I've already got the king of hearts, right? And inside this over here, I've also got the king of hearts. But you and I both know there's only one king of hearts in the entire deck. And I've counted it twice. So therefore, I must subtract one of those king of hearts so that I don't double count. And that leaves me with 1 out of 52 and a result of the following. A result that says 4 plus 13 is 17, minus 1 is 16, 16 out of 52. The denominator is all the same, so I can count in this manner. Okay, and so here's the formula that's given to you. Is the probability of event A or B occurring is equal to the probability of A plus the probability of B minus the probability of A and B. Now, if the events are mutually exclusive, which is what we learned in the previous video, the value of this intersection here is 0 because A and B cannot occur at the same time, and then that simply falls away when we're dealing with mutually exclusive events. If the events are not mutually exclusive, then we must use the entire formula as it stands over here. Okay.